Welcome to Mr. Gee's Math page again. Right now in my algebra class, we're simplifying monomial expressions with exponents. We've just barely started chapter 8, so students are getting more familiar with how to multiply like bases with exponents. The directions read: simplify the following monomial expressions. Please show the expansion of like bases using the power rule, the addition of exponents when we're using multiplication, or the cancellation of exponents that goes along with dividing or division. We'll go ahead and start with a nice simple one. We'll go ahead with problem number 1. Let me bring up my layer here and have me something to write with here. And zoom in. Nice simple problem. Now, one thing that you've got to remember, if I look at x squared, if I just have x squared, the x squared is the base and the 2 is the exponent. When I have something written like this, things change a little bit. This whole thing is now the base, and yes, that's an exponent, and there's also an exponent of 1 there, but now the exponent that operates on this base is the 3. So what this signifies here is that I need to multiply this group of symbols needs to be multiplied together 3 times. And I'm going to do this a little bit differently than what I've shown in class, to maybe show a different concept and idea. So this says I take 6x squared y times 6x squared y times 6x squared y. And remember, there's an exponent of 1 on everything. Now we can see here I've got 6 times 6 times 6. I've got x squared times x squared times x squared. And then last of all, I have y times y times y. And they all have a 1 exponent. Now the basic rule says that if I have like bases, and when I multiply like bases, I add the exponent. So this actually becomes 6 to the 3rd, because there's a 1 on each one of those, 6 to the 3rd. And then I have 2 plus 2 is 4, 4 plus 2 is 6, so that's x to the 6th. And then y, I have 1 plus 1 is 2, 2 plus 1 is 3, so y to the 3rd. Now the last thing that I have to do is you'll have to take out a calculator, take 6 to the 3rd power, and that should be 296. Let's see that. So I got 6 times 6 equals 36, and times that by 6, so that would be 180, and 36, so it's 216. So 216 x to the 6th y to the 3rd would be our final answer for number 1. So the basic idea is understanding that the exponent tells how many times a base is used as a factor. That's principle number 1. The other principle is that when we multiply like bases, we always add their exponents. The next problem that we'll do is problem number 5. It's very similar to the last one we did in that we have a base raised to an exponent, and then we have a base raised to an exponent. And on your worksheet, I think you need to fix that x to the z. That z actually needs to be a 2. Alright, so from what we did from the last problem, we're going to have 2 of these, because this is this base raised to the 2 power, so that's 4x squared y to the 1st times 4x squared y to the 1st 4 times 4 is 16. X squared times x squared is x to the 4th. And then y times y would be y squared. Okay? Some of you might like to do it like this. We know 4 times 4, we've got x squared times x squared. Then we have y to the 1st times y to the 1st. 4 times 4 is 16. Add the 2's on the x, so x to the 4th, and add the 1's exponent to the y will give you y squared. Now that's just the first piece that we need to do. That gives me the answer to this first factor. Now we have to do the second one. So we've got 2 times 2, then we've got x times x, then we have z times z. 2 times 2 is 4. X to the 1st times x to the 1st is x squared. And z to the 1st times z to the 1st gives me z squared. Now that I have these two smaller answers, we're going to combine these two together, and we'll get the final answer to our problem. So let's group our numbers together. So 16 times 4, 16 times 4, I have x to the 4th times x squared, x to the 4th times x squared, and then I have y squared times z squared. 4 times 16 is 64. X to the 4th times x squared. Remember, I add the exponents. That's not x to the 8th, it's x to the 6th. Y squared is just by itself, so it stays just like that. Z squared is by itself, so it just stays as z squared. So the final answer for number 5 is 64x to the 6th, y squared, z squared. Now, one thing that's customary in math that I ought to mention right now, when we have variables, we always write them in alphabetical order. Is there anything wrong in having z squared, x to the 6th, y squared? No, but it is just customary to always write them in alphabetical order. The next problem that we'll do is problem number 9, which involves dividing one monomial by a second monomial. And we do this just a little bit differently. Because we're doing division, we are going to show the cancellation of exponents by using various forms of 1. Now, the principle behind this is based upon this. Let's take a look at b to the 7th. B to the 7th is also written as b to the 4th times b to the 3rd. It can also be written as b to the 6th, b to the 1st. But when we take a look at what we have here, b to the 7th and b to the 5th, what would really make it nice, let me rewrite this here, is to have b to the 7th written in the form where I have a 5 instead of a 4 over 3 or a 6 or a 1. I want to have a 5. So I could write b to the 5th times b squared over b to the 5th. Now we know from just a long time ago in math that anything divided by itself, if I have the identical thing on top and then the identical thing on the bottom, that always equals 1. So anytime we're dividing a monomial by a monomial, that is the principle that we want to use to simplify. Okay, with that being said, we'll go ahead and start this problem. 14 is the same as 2 times 7. 7 squared is 7 times 7. There is my cancellation. 7 over 7, so that's going to cancel as 1 to 1. Now let's look at a. I have a to the third over a to the first. Well, how can I rewrite a to the third to allow cancellation of a to the first? Well, let's rewrite a to the third as a squared times a to the first. There's my cancellation of 1. Well, let's do the same thing with b. I know I have b to the fifth on the bottom. Well, there's a b to the fifth hidden inside of b to the seventh, so I will write b to the fifth times b squared. And the same principle will work with c. I've got c to the first. I want to rewrite c to the third so I can get rid of c to the first on the bottom. That's my form of 1, and then I have to have a c squared there. Now let's go through and cancel out all my forms of 1. That cancels. 7 over 7 is 1. a to the first over a to the first is 1. b to the fifth over b to the fifth is 1. c to the first over c to the first is 1. So now my final answer is, draw my division bar, 2 over 7. A squared is on top, b squared is on top, and c squared is on top. So that's our final answer to number 9. The last problem that we'll do is number 11. You can see that inside of it that we have a monomial divided by a monomial, but it's also raised to a power. So what we do with this one, we treat it like we did number 9. We're going to simplify the monomial inside, the division of the monomials inside, and then we apply the power rule. So let's ignore the power rule and let's just concentrate on what we have here. So I've got 2 over 6. We know that will equal 1/3. Now I have a squared and a to the third. Well, I know a squared can stay like that on the bottom, but I need to write a to the third because there's a square hidden inside the a to the third. I can write a to the third as this, and then I can see the a squareds cancel. I have b to the fourth on top, and b to the seventh has b to the fourth inside, and that will leave me b to the third power left over. And now on top here I have c to the first, and c to the second has a c to the first inside of it. So now I've broken everything apart where I can cancel the pieces I need by 1. So that will give me 1/3. The a squareds cancel, so I just have a on top. B to the fourth power cancels, so I have b to the third on the denominator. And then c to the first cancels on the top and the bottom, so I just have c to the first also in the denominator. Now this will become a to the first over 3b to the third c to the first, and it's all raised to the third power. Now this factor will be used 3 times as the base. I will write this just a little bit different. 3 is multiplied together, or a is multiplied together 1, 2, 3 times. 3 is multiplied together 1, 2, 3 times. B to the third is multiplied together 1, 2, 3 times, and c to the first is multiplied together 3 times. So I know that's a lot of writing there, but this makes it a little bit easier to see what's going on. So a times itself 3 times is a to the third. That's my numerator. Then I have 3 times 3 times 3, that's 27. B to the third would be 3 plus 3 plus 3 is b to the ninth. And then I have C, 1 plus 1 plus 1 is 3, so C to the third. So that is my final answer for number 11. Well, thank you for tuning in, and remember you can download these worksheets at Mr. Gee's Math page. You can do a Google search for that and go to the link. It says Worksheets and Videos. Click on there, and this should be under Chapter 7, Worksheet 8.1A. Thank you for tuning in, and if you would like to subscribe to my YouTube page, that would be very much appreciated. Thank you.